So example 2 gives us a different graph, and again, we're just going to fill out the main characteristics. We are going to add arrows and the ends. Now, this one doesn't have a vertex, so as definition, vertex is either the highest or the lowest. We don't have that, but we do have this thing called inflection point. So I'm going to cross it out and write inflection point. Inflection point, students, it's where usually it happens in a cubic, usually. It's where we have a graph that changes from opening upward, as you can see here, to opening downward, okay? So we have an inflection point here at -2 comma, looks like that's a 3. So -2 comma 3, okay? X-intercept, definitely. X-intercept for this one, let's just make it nice and round it to -1. So that's going to be a -1 comma 0. The domain, again, with the arrows on the left, that means it goes left forever. Arrows on the right means it goes right forever. So that's going to be all reals. Now, and I do want you to write both notation, students, all real or from -infinity to infinity. So we want to know how to write it. This is, again, called interval notation, okay? Increasing interval. Increasing interval meaning that, hey, is there a, as we write it from small x to large x, okay? So small x value, comma, larger x value. Is the y going up? Well, ask yourself, can I slide down the entire graph? Or can I hike up? So for this, for this particular function, it's a sliding down kind of graph, right? It doesn't matter where we end up. Can you guys see that? We can only slide down. If you can hike up, okay, hiking. So if you are hiking up, then that's when you know that we can say that it's an increasing notation. But if you can slide down, then that means it's a decreasing interval. So decreasing all over the entire graph. So that means the smallest x has to be -infinity and the larger x has to be +infinity. Rate of change only happens if we have a line or an absolute value function. So for this one, next year, you're going to learn what it is. Right now, we're going to say it varies. Minimum value. Minimum value, students, mean, hey, is there a smallest y value that we can pinpoint? And the answer is no. It's about putting arrows on these ends. So minimum value is NA, or you can write none. Axis of symmetry. Axis of symmetry is a line that divides the graph into perfect halves, and that's not possible. So for this one, we can say none or NA. Y-intercept. Yes, we do have one. Looks like, I'm going to approximate that about -5. So y-intercept is 0, comma, -5. The range is listing out all the y values. The smallest y value is -infinity and the largest y value is +infinity. So -infinity to +infinity, that's your interval notation. Or right now, we can also write all real numbers. Now, this happens to be decreasing the entire time, students, because we talked about how we can slide down, right, students? This, we can slide down. Whee! Yay! Okay, the entire function is going downward. So it's going downward over the entire domain. So -infinity to infinity. Next, is it a one-to-one function? Okay, so to make sure it's one-to-one, you want to check to see if it's a function first. A function is, remember, every x value, we can only have one y. So you make your vertical line test, it can only intersect it once, which does check. Now, a one-to-one is a special function. So not only that it has to be a regular function, every y value, does it only have one x? And that is true. So, because the horizontal line test only crosses over once. So this is a one-to-one. Yay! Maximum value is none or NA, because maximum is the highest value, and because of the arrows going upward, there is no such thing.